Article 430.102b addresses manually operable motor disconnects. The motor disconnect means must be manually operable and capable of being locked in the open position. The disconnect means must be located within sight of the motor location. There are a couple of exceptions to the rule. Exception number 1 addresses fixed motors. Disconnect means that are within sight from the motor location and are capable of being locked in the open position may be used. These include circuit breakers, fuse switches, and motor circuit switches. Exception number 2 addresses motors over 600 volts. Disconnect means located at a remote location are permitted. For a submersible well with a pressure switch located inside a basement next to a pressure tank, and with a service entrance to the home located in the same room and within sight, about 10 feet away from the pressure switch, the circuit breaker in the service entrance may satisfy the requirements of Article 430.102b exception number 1 because it is within sight from the pressure switch location and can be locked in the open position. Therefore, an additional manually operated lockable disconnect switch in the vicinity of the pressure switch may not be required in this situation. It is important to consult the latest edition of the National Electrical Code, or NEC, and local amendments to ensure compliance with all applicable regulations. Always consult with a qualified electrician for specific applications. The motor disconnect requirements in Article 430 are designed to ensure safety during maintenance and repair of motor-driven equipment. The ability to lock the disconnect in the open position prevents accidental energization of the motor while work is being performed. The location of the disconnect within sight of the motor allows for easy identification and control of the power source. Understanding these requirements is crucial for electrical contractors, maintenance personnel, and anyone working with electrical systems that include motors. The exceptions to the rule provide flexibility in certain situations, such as when the disconnect is readily accessible and lockable, or when dealing with high-voltage motors. However, it is important to carefully evaluate each situation to ensure that the chosen disconnect method meets the intent of the code and provides adequate safety. When evaluating whether a circuit breaker meets the requirements of Article 430.102b exception number 1, consider the following factors. Firstly, the circuit breaker must be within sight of the motor location. This means that the breaker must be visible from the location of the motor or the equipment it drives. Secondly, the circuit breaker must be capable of being locked in the open position. This can be accomplished by using a lockout device that attaches to the breaker and prevents it from being switched on. Thirdly, the circuit breaker must be readily accessible to qualified personnel. This means that the breaker must be located in a place where it can be easily reached and operated. The NEC defines in sight from as being visible and not more than 50 feet distant. So, for example, if the motor is located in a separate room or building, the circuit breaker would not be considered within sight. In such cases, a separate disconnect switch would be required at the motor location. Also, consider the voltage of the motor. Exception number 2 applies to motors over 600 volts, allowing for remote disconnects. Motors operating at lower voltages generally require disconnects within sight of the motor, unless exception number 1 applies. The type of motor is also important. Fixed motors, as mentioned in exception number 1, are typically those that are permanently installed and not easily moved. Portable motors may have different disconnect requirements. Always refer to the specific requirements of Article 430 and other relevant sections of the NEC to ensure compliance. Remember, electrical codes and regulations are in place to protect people and property from electrical hazards. Ignoring these requirements can lead to serious injury, death, or property damage. If you have any questions or concerns about motor disconnect requirements, it is always best to consult with a qualified electrician or electrical inspector. They can provide expert guidance and ensure that your electrical system is safe and compliant with all applicable codes. In addition to the specific requirements of Article 430.102b, it is also important to consider other relevant sections of the NEC when installing motor disconnects. For example, Article 430.109 covers the types of disconnects that are permitted for different types of motors. Article 430.110 covers the rating of disconnects, and Article 430.111 covers the location of disconnects. To elaborate further on the different types of disconnects permitted, Article 430.109 outlines that the disconnect means must be a horsepower-rated switch, a motor circuit switch, or a circuit breaker. The disconnect must be able to interrupt the motor's stalled rotor current. The NEC provides tables to assist in determining the appropriate size disconnect based on the motor's horsepower and voltage rating. Article 430.110 dictates that the disconnect mean shall have an ampere rating of at least 115% of the full load current rating of the motor. This ensures that the disconnect can safely handle the motor's normal operating current. For motors with higher starting currents, a larger disconnect may be required. Article 430.111 specifies that the disconnect means must be readily accessible. This means that it must be located in a place where it can be easily reached and operated without having to climb over or move objects. The disconnect must also be installed so that it is protected from physical damage. Consider the environment where the motor is located. If the motor is located in a damp or corrosive environment, the disconnect must be rated for that environment. This may require the use of an NEC enclosure, which is designed to protect against water, dust, and corrosion. Proper labeling of the disconnect is also essential. The disconnect must be clearly labeled to indicate the equipment it controls. This helps to prevent accidental shutdowns or startups of equipment during maintenance or repair. The label should include the motor's horsepower, voltage, and full load current rating. When selecting a disconnect, it is important to consider the motor's starting method. Motors that are started using reduced voltage starters may require different types of disconnects than motors that are started across the line. This is because reduced voltage starters can create harmonic currents that can damage disconnects. In some cases, it may be necessary to use a disconnect with a higher interrupting rating to handle these harmonic currents. Another factor to consider is the motor's duty cycle. Motors that operate continuously or frequently may require disconnects with higher endurance ratings. This is because the contacts in the disconnect can wear out over time, especially when subjected to frequent switching. The NEC also addresses the use of electronic motor controllers. Electronic motor controllers are devices that are used to control the speed and torque of motors. These controllers can also provide overload protection and other features. When using an electronic motor controller, it is important to ensure that the controller is properly sized and installed. The controller must also be listed for the application. Furthermore, NEC Article 430 provides guidance on overload protection for motors. Overload protection is designed to protect the motor from damage caused by excessive current draw. This can be caused by a variety of factors such as a locked rotor, a stalled motor, or an overloaded motor. Overload protection is typically provided by an overload relay or a circuit breaker. The overload relay is a device that senses the current flowing through the motor and trips the circuit if the current exceeds a certain level. The circuit breaker is a device that automatically interrupts the circuit if the current exceeds a certain level. When selecting overload protection, it is important to choose a device that is properly sized for the motor. The overload protection must be able to protect the motor without tripping unnecessarily. The NEC provides tables to assist in determining the appropriate size overload protection for different types of motors. Additionally, the NEC also addresses the use of ground fault protection for motors. Ground fault protection is designed to protect people from electric shock caused by ground faults. A ground fault occurs when a motor's insulation fails and the motor's current flows to ground. Ground fault protection is typically provided by Ground Fault Circuit Interrupter, or GFCI. The GFCI is a device that senses the current flowing through the circuit and trips the circuit if the current flowing to ground exceeds a certain level. GFCI protection is required for motors that are located in damp or wet locations such as swimming pools, fountains, and spas. In addition to the NEC, there may be other codes and standards that apply to motor disconnects. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for motor disconnect. These standards cover the design, construction, and performance of motor disconnects. The Occupational Safety and Health Administration, or OSHA, also has regulations that apply to motor disconnects. These regulations require employers to provide a safe workplace for their employees. This includes ensuring that motor disconnects are properly installed and maintained. When working with motor disconnects, it is important to follow all applicable codes and standards. This will help to ensure that the electrical system is safe and reliable. Remember to always energize the circuit before working on any electrical equipment. This will help to prevent electric shock. Use appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and insulated tools. This will help to protect you from electrical hazards. Inspect the equipment before use. Make sure that the equipment is in good condition and that there are no signs of damage. Follow the manufacturer's instructions. This will help to ensure that the equipment is used safely and effectively. If you are not qualified to work on electrical equipment, do not attempt to do so. Hire a qualified electrician to perform the work. This will help to ensure that the work is done safely and correctly. Furthermore, consider the specific requirements for submersible well pumps. These pumps are often used in residential and commercial applications to provide water for drinking, irrigation, and other purposes. Submersible well pumps are typically located deep underground, which can make them difficult to access for maintenance and repair. The disconnect for a submersible well pump should be located in a readily accessible location, such as near the wellhead or inside the building. This will allow for easy disconnection of the pump for maintenance and repair. The disconnect should also be properly labeled to indicate that it controls the well pump. The wiring for a submersible well pump must be properly sized and installed. The wiring must be able to handle the pump's full load current and starting current. The wiring must also be protected from physical damage. The NEC provides specific requirements for the wiring of submersible well pumps. These requirements cover the type of wiring that is permitted, the size of the wiring, and the methods of installation. In addition to the wiring, the submersible well pump must also be properly grounded. Grounding is designed to protect people from electric shock caused by ground faults. The grounding wire must be connected to the pump's metal casing and to a grounding electrode, such as a ground rod. The grounding electrode must be installed in accordance with the NEC. When installing a submersible well pump, it is important to follow all applicable codes and standards. This will help to ensure that the pump is safe and reliable. Remember to always energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. Inspect the equipment before use. Follow the manufacturer's instructions. If you are not qualified to work on electrical equipment, do not attempt to do so. Hire a qualified electrician to perform the work. In summary, understanding and applying NEC Article 430 regarding motor disconnect means is crucial for electrical safety. The article emphasizes the importance of manually operable and lockable disconnects within sight of the motor location. Exceptions exist for fixed motors and motors over 600 volts, providing flexibility under specific conditions. Careful consideration of factors such as motor voltage, type, and location is essential when determining disconnect requirements. Additionally, adherence to related NEC articles, NEMA standards, and OSHA regulations ensures a safe and compliant electrical system. Always consult with qualified professionals for specific applications and prioritize safety when working with electrical equipment.